Hello friends, today we will discuss about some important concepts of C# programming. As we already studied about how to create a method, how to use the access specifiers, access modifiers along with the parameters, and today is the list of topics. It is related with the methods also. First one is how to call a method in C# with the types. What are return types of methods? What is recursion concept along with the types in methods? So we will see all these concepts one by one with the example. So let's begin. First topic is calling a method in C#. To how to call a method in C#. To calling a method, it means executing a method's code by using its name followed by parentheses, optionally passing arguments. When a method is called, program control jumps to that method's code, executes it and returns to the calling point. As we already know how to call a method, as we already know, if we want to call a method, invoke a method, then we have to use these parentheses, means brackets. Without it we cannot call any method or invoke any method. So for calling any particular method, we have to use these parentheses, or if we have any other parameters, then we can define into these parentheses also. And the cursor starts from while invoking that particular method name, and then it moves to the declaration part where we actually declare that method with the logic. After executing the proper method, and then it returns where we called the method, means if we are calling display value method, then it again comes to that method where we are calling. So that is calling a method through the class name, or while if we are want to create any instance, then we can call that method through the instance also. Next we have some points. Methods can be called from within the same class or from the other classes based on access modifiers. As I already told you, we can create the instance of that class. With that we can call that method. Otherwise we can use that class name, directly use the class name with the method name if we have some specific static methods. Arguments must match the parameters list of the methods. If we are using any arguments, means parameters, we have to match that sequence with the method declaration where we declare the method. These parameters should be matched, means integer, string, these should be matched in the proper sequence. Here we have some types of method calls: instance method call, static method call with the parameters, method call with return value, method call via named parameters, recursive method calls. So we see all these methods one by one with the examples. First is instance method call. Create an object and call the method. First we have to create the instance of the class, then we can call that particular method with that method name. So this is the instance method call with parentheses. Next one we have static method call. It calls directly using the class name, no object needed. We don't need to create any object, any instance of that particular class. We can directly use the class name and with the method name and along with the parentheses. So this is the simple way of calling a method if we have any static method available. Next one we have method call with the parameters. To pass arguments matching the parameters list. If we want to pass some parameters along with the method name, then we can do this way. Let's first see the instance method call. Suppose we have some random class, new class. Here we can create some method value line instance method calling. So this is the instance method calling method call. For this we have to create an instance, means object in that particular main method where we are invoking this method. First we have to create the instance of my new class, then we can call this particular method display values. So this is the instance method call. First we have to create an instance, then we can invoke that particular method. Here we have the result which we are displaying instance method calling. This method we are displaying through this display value, and this is the instance method call. Suppose if we want to call it directly with the class name, we can do this way, okay, but we have to set this one a static method because we are calling into the static method. So for this it is must we have to have the static method which we are calling. So this is the static method call. So now we have the same messages. Suppose static. Now let's see the. Now we have the static method calling. We are not creating any object, we are not creating any instance of the class, we are directly using the class name and directly using the method name with the parentheses. Okay, suppose if we want to send some parameter, then we can do this way. Here we can pass some value like this, parameters method call. So this is the parameter method call. We are sending some values through this method. Now we have the value which we are passing, means 30, through this method display values. So this is a parameter method call. First one is if we want to create any instance of that particular class, then we can call this or invoke this method. Second, if we want to create any static method, then we can directly use the class name along with the method name with the parentheses. Third one we have if we want to send some parameters through that method, then we can do this way. So these are the three types. Next types we have a method call with the return values. Store the result in a variable. Suppose if we want to return some values through that particular method where we are calling, then we can do this way. First we have to receive these values into any integer. If it is integer returning, then we can assign it as integer value, otherwise we can assign it as a string value if we are returning string value. So this is the method call with return value. Method call via named parameters. Pass arguments by explicitly naming them. As we already know about these named parameters, we have to set the variables names, not the sequence. If it is not in the sequence, it will invoke that method, but it should have the same variable name as age as where we declare the method. So this is the name parameters. Third one we have recursive method call. Method calls itself. If we want to invoke that particular method inside that method, then we can do this way. This is the method name and we are passing some values. Suppose here we want to get that particular value. Instead of writing void, we can send some value here. and we must have to return something like here we can send 50 value, and here we have to receive that particular value. So this is the returning value method call, where we are getting the value which we are returning from our main method. Now let's see the result. First we can display this one also, the final value. Value. Now we have these values. First one is as it is, as we are calling that inside or displaying the message inside that particular method. Second one, we are returning 50 as a return type of integer into this particular method, and here we are getting this value into an integer because it is an integer value. If it is a string or boolean value, according to that we have to set the data type here, and then we display this particular value, means 50 here. Next if we want to use the named parameters, here we can set some text value, string value, text value, and here we can use named parameters, meters, can send programmers. So this is a normal flow of any calling method, but if we want to use the named parameters, we can do this way. Value. So this is a proper flow of named parameters, as this is in sequence. If it will not in sequence, it will definitely invoke this method, because sequence doesn't matter here. Only matters here is the variable name should be same as where we declare the method, means the string value is same variable name and integer value also have same variable name. Now let's see this one. We have an error. One second. Yes, now we are getting the values 30 value and string value, that is programmers. As it is, we are getting the returning value 50. So this is the named parameters, where a sequence doesn't matter, but what the matter here is the variable name should be same, and here we are returning same as it is values. And next one we have the recursive function. Suppose here we want to call this method again inside of this method, so we can do this way. First we have to put some condition that if this condition will match, then only this recursive function will call. Here we can set some value along with the text value. Yeah, we can remove this one. For now we doesn't need this one. And then return some value. So this is the recursion means call method by itself only inside that particular method. This is the recursion part. Now let's invoke this method here. First we have to pass some values. Enter result. Right line. Here we have the display values and context. We have to use class name here. Now let's see what it will give us. Now we have all the values. First here we send 100 value, and then it will display that 100 value with this message. Okay, but this condition is not satisfied, as it directly moves to return portion and returns 50, and it displays us 50 value. Suppose if we want to use this recursion portion, we have to satisfy the value here, and we can send here 10. Now it will satisfy this condition, and then it will change the value with 20 if we again call this method. Now here we have three values. First one is, as it is 10 value, it first displays 10 value, and then the condition satisfied here means we send 10, and then this value is true. So it calls the recursion, means call that particular method again, and here it displays 20 values, as we are sending 20 into this parameter, into parentheses, as it displays 20. And after this the condition will not match, because here is 20 and here is 10, so here the condition was false, and it returns 50 again. So here we have 50 value in return. So this is the main concept of recursion, means if we want to call that particular method inside that method, then we can do this way. It totally depends on the requirements. If we have any program requirement, then we can use this recursion, but we have to set some condition. So this is the base condition. If we want to use that recursion, because without it, it will behave like an infinite loop, because it is calling this method again and again. So this is a portion of returning value. Method call means we want to return some value, and next if we want to use name parameters, third one is recursion. Next we have return types concept. The return types of a method specifies the types of a value it will send back to the caller. Return type is like if we declare any method, which kind of value we want to return. In return, like integer value, string value, boolean value, or a list type of value, any kind of value we can return into any particular method. So that is the return type. If no value is returned, the return value is void. If we do not want to return any value from inside that method, then we have to set this void, as it will show that we are not sending any value. So this is the return type, that is void. Here we have some types: primitive types, reference types, custom types, along with the generic types. First one, we have primitive types. It represents simple values stored directly in memory. So primitive types are like it directly stored to that particular memory, not that reference value. So this is a simple values which stored directly. Its types are integer, double, char, bool. Here we have the example. Here is the method name, and we are returning some value like 42 here. So this it will store that value directly to the memory. Second, we have reference types. It will not store that actual data into the memory. It will store the reference of address to that particular data. It stores a reference address to the actual data in memory, as I already told you. So here we have the types like string, array, integer of arrays, classes, my class, like that. Example we have here, we are returning some string value. So it is not storing that value directly to the memory. It is storing the reference of the data. Now let's see the primitive types. Suppose here we are sending some integer value directly. So it stores this value directly to the memory, not the reference one. Here we do not need to require the parentheses or parameters value. We only need to invoke this particular method and return that integer value. So this is the primitive types. Types. Here we have the result, that is 50. We are getting 50 as a return type through this method. Next, if we want to send some string value, then we can set the return type as a string. Here we can send like developers. So it will not directly store this value into the memory. It will store the reference of the address of that into the memory. So these are reference types. And here we have to change the type also. So these are reference values. Now here we are getting the reference value, that is developers. We are returning reference value through this particular method. So this is the primitive types. If we want to send some like double value or any integer value which stores directly that data into that memory, so that are primitive types. And reference types are opposite to that. It will not store directly that original value, but it stores the reference of the address of that value into that memory. Next we have custom types. So what is custom types? Custom types are user defined data types created using class, struct, enum or interface. Interface, class, objects, struct, enums, we will study it in later videos. They allow you to group related data and behaviors into a single type, making code more organized and reusable. Custom types are like some user defined data types which we can create using class or struct or enums or any interface. It is like to change the behavior of that particular method into a single type, and it will make the code more readable, more organized or more in a sequence, like that. Here we have some types, class, struct or enum. Here we have the examples of custom types. Here we are creating some person model, here class person model, and we are creating some variable property name for that person. Now we are using this one into this method, get person method, where we are creating the instance of that person and we are assigning the value to that name. And in the main method we are displaying this method or invoking this particular method with the name, same as that in struct. Here we are creating the instance of that point model and we are displaying this model through this main method. Here we have two new things like one line, more than one line. One line means expression body. If we have only one line code, then we can go with the expression body like this. Here we are creating some method and we have only one line of code, then we can go with this approach with the lambda expression. This is called lambda expression. Here we are directly creating the instance into one line. So anywhere if we have only one line of code, then we can go with this one approach. Otherwise, if we have multiple lines of code, then we can simply use as it is block body, as we are already using this one, more than one line of code, then go with block body. Here only this into this scenario we have one line of code, then only we are going with expression body. Otherwise we have to go with block body for the multiple lines of code. Now let's see the custom types. Here we can create some demo class for this new user. Here we initialize some string value like username. So it is a kind of a model, and here we want to use the expression body. If we have a single line of code, then only we can go with this one. First we have to create some particular method, new user, then the username. Then here we directly create the instance of that method, and here we have to initialize its value, means username, and give programmers. So here we create some method and initialize the new user object here, and we assign the value to that username. Suppose we have some static main method like this one, and this one also we have a single line of code, then we can go with this approach. We can directly use the console.writeLine. Expression value. First we have to call this particular method with username. We want to display this username. Now let's see what will be the output of this one. Now we have the value programmers, expression value programmers, which we are assigned into that particular method while creating the new instance of the new user model. So if we have one line of code, then only we can go with the expression body. Otherwise if we have multiple lines of code, then we can go with the block body, as it is we are using like this way. Next one we have struct. It is also same as that. It is a custom types also. Struct value. So it is giving us the struct value, that is programmers, same as it is. Only in that case or in that scenario, if we have one line of code, then only we can go with this one approach with lambda expression directly. Otherwise we have to follow this block body approach. So this is block body approach. Next one we have generic types. Generic types are type-safe data structure that allows you to define classes, interfaces, and methods with a placeholder for the data type. They make code more flexible and reusable without sacrificing type safety. Generic concept we will also cover into later lectures. Only now we have to see the custom types. For this purpose only we have to use this generic types. So it is like data structure type safe, which we can use If we want to use any list type or task type in any asynchronous method, as we already study about that asynchronous calls, then only we can use with generic types, where we can set the value of type, and it makes code more flexible and more reusable. We can use that code again and again in anywhere into that particular program or into your application. Here we have built-in types like a list type, values of type. Here we can put any type like integer, string, boolean. Like dictionary, we have type key or type value. Task, we already study about this value of type, where we put some integer value, string value also. Here we have user defined types, where we can go with the class, where we can define these types into that particular class. Here we have list type of values. We are creating some sort of list of integer, and we are just pushing that data into that list, and we are displaying this list type with the for each loop. Next one, we have a task value of t. Here we are passing string values through task, and we are displaying this value through this await function. Now let's see the list type and task types. Now we can go with this one. First we can create some static list of types. We can put some integer values into that list. Get values. Here we can use this lambda expression, as we have only one line of code. New list of integer. We can put some values like this one. Now we have this list, integer of list, means 3 values into that list. Now here we can call this method. Suppose if we want to call this one, we have to use for each like this. Now it will print all the values into sequence. Here we do not want to use the method means parenthesis for the write line, because it already understands it as there is only 3 values, and it will displays it in sequence. Now let's see this one. Here we have all 3 values 10, 20, 30 in sequence order. So here is the thing, if we want to create any list type of integers, any string type, we can do this way and display these values along with for each loop. And in the same way, if we want to use a task, here we can put some string value, get task values. Here we have to initialize it differently. From result, where we can put some value like CSharp. Now we have to call this method. Inside that, console.writeLine method get task value. Task value. Now let's see the result of this one. As it is not displaying the result. You know why? Because we are not using await keyword here. If we want to invoke any asynchronous method, we have to use the await keyword here, and in in main method also, where we are calling this or invoking this particular method. Now it will display the result. Here we have the task C# value. We are invoking C# value through the asynchronous method, asynchronous call. So this is the thing about a list of integer and task of string or task of integer we can use. Next one we have recursion is C#. So what is recursion? As we already studied about recently about recursion, to call a method inside that particular method, so that is a recursion. Recursion is a programming technique where a method calls itself directly or indirectly to solve a problem. Means if we want to use some conditions where we want to call that particular method inside that method, then that is known as a recursion. It usually has a base class or recursive calls. Base class is like if we have to put some particular condition that the recursion is invoke only once, not it will not creating any infinite loop. For this we have to use base class, means some particular condition to stop the recursion. Recursive call method calls itself with updated parameters. If we call that particular method inside that method, we can pass some different variables, means different values through parameters. Here we have some types of recursion like direct recursion, indirect recursion, tail recursion, non-tail recursion. We can see all these one by one with the examples. First one we have direct recursion. Method calls itself directly. Where we have this method and it is calling itself directly, so this is known as direct recursion. Inside the particular method, it is calling itself. Next one is indirect recursion. Method A calls method B, which calls method A. Suppose we have multiple method, means more than two methods or two methods, then if we are calling the method from one another, like here we are calling method B from method A and method A from method B, so this is a kind of indirect recursion position. Next one we have tail recursion. The recursion call is the last statement in the method. Suppose we have some sort of method and we put some we are calling that particular method only to the last, not on the start or on the middle of the execution into that method. If we are like putting or calling that particular method into the last, then it is called as a tail recursion. No other operations we are performing before this method, so that is tail recursion. Next one we have a non-tail recursion. The recursive call is not the last statement, other operations follow it. Non-tail recursion is opposite of tail recursion, as we are performing some operations before calling that method itself. Here we are like using n or multiplication with that method calling. So this is the non-tail recursion situation, where we are using or calling some operations before calling that method itself. Now let's see the direct recursion. Suppose if we are calling some single method, direct recursion, means the method calling itself inside that particular method, but here we have to use the base value to stop the infinite loop situation for recursion. Means to stop the recursion process we have to use some basic condition into any particular method. We can some value, we can use some parameters here. If only this condition will match, then only the recursion will effect, otherwise it will return. No need of any return. Here we can pass some new value. Now let's call this one inside the main method. We can send some 10 value. Here we can display some values. What values it is? I'm putting direct recursion. Now this method should be static, as we are calling that method inside that static method. Here we can put void. Now let's see what it will give us. Now we have the two values. First we are sending 10 value and it just displayed this value like 10, and then conditions was matched. As we are sending 10, the condition was matched, and then it calls that particular method again one time with the new parameter value means 20. So second time it will invoke inside itself, then it will print 20. So this is the direct recursion, where we are calling the method inside that method. So that is the direct recursion process. Suppose we have indirect recursion, where we are not calling that particular method inside that method, but inside the some other method. So this is the indirect recursion, and this one is the direct recursion. If conditions will match, then it will call this indirect recursion method inside that method. Here we have to use this one. Yeah, let's check this one. Here we have two values. First one is direct recursion and second one is indirect recursion. First we send 10 values in direct recursion. Okay, now here is the thing, it displayed the 10 value for direct recursion, and the parameters value were matched, condition was matched, and then it invoked this indirect recursion with the new value means 20. So it displayed this 20 value, but inside it will not invoke this direct recursion because the condition was false here, because we send 20, already we changed this value inside that direct recursion method. So the value is changed according to that, and it will not call this one. So this is the situation of indirect recursion, where we are having multiple methods and we are calling the multiple methods inside that another particular methods. So this is the kind of situation of indirect recursion. Next we have tail recursion. Suppose public static anything if we want to send, otherwise we can go with the void tail recursion method. Int number. So dot right line, where we can display some particular value tail recursion. Here we can display this value, and we put some condition to stop the infinite recursion. Here we can set some value like 50, return some value in integer format. So this is a tail recursion. Where we are calling the method itself, but in the last of the execution part, means into this method but into the last of this line. So this is the tail recursion. If we want to use this one, we have to call this statement at last, but no operations should be performed other than the invoking this method. Suppose if we want to call this method some variable like 51. Now let's see the result of this one. So this is the situation of infinite recursion, where it is not stopping this loop because the conditions are not matched, and it invoke this particular condition for an infinite loop. Now if we want to stop the recursion, then we have to pass some value where it will return through this. Now it will not create any infinite recursion situation. Here we have two values, 51 and 50. Here we are passing 51, then it displays as 51. Now we again call this method itself and we pass 50. So it passes this condition, and from this it returns from here inside that loop. So this condition, as you already saw this one, it is very important. So this is the base condition. So in any recursion process we have to use this one. It is must. Without it, as we already saw this one, it will create an infinite recursion situation. Means infinite creating any loop. So if we want to stop the recursion, then we have to use this particular condition. So this is the tail recursion. Next, if we want to the non-tail recursion, can create some static method here. Numbers. Integer age. We can display the particular value inside this one. Non-tail recursion age. Age is equal to 20, then it will return. Otherwise it will call that particular method number value inside it. So if we want to use a non-tail recursion, we can put some values like here. We are performing some operations like this. So it is a non-tail recursion process where we are performing any operations at last of the statement with the recursive call of that particular method. Then this is the situation of a non-tail recursion. Here we have to return this value also. First we have to call this one. We can use 30. Then now it will create and return age. Now let's see what it will give us. Here we have two values, that is 30 and 20. First we will pass 30 and then it will prints the 30 value, and then it will give us 20. As first time the values were not matched, and it will directly move to this one where we are calling this method along with some operations, and then we are passing 20 value, and then after second time we call this method, then the conditions were matched and it returned that particular age, but we are not getting the current value. So if we want to get the current value, then we can use this way. We can display this value after operations with the last statement. Result value, that is value. Here we have three values, as it is two values 30, 20, and now we have the final value, that is 50. How it comes? Because as we performed the addition operations at the last of the statement with recursive call, so it added the 20 value with the 30, so it becomes 50. We get final value here. First time we send 30 value and then it displays 30 value with this, and then we change the value with the 20, and then it match the condition with this one 20, and then age 20, that is 20, so that is the returning value 20, and this is the value which we are adding. First one, that is 30, first we send it 30 value, so 30 plus 20, that is 50. We are getting 50 here, and then we display this value here. So this is the non-tail recursion. We are getting 50 value. Here we saw all these that direct recursion, indirect recursion, tail recursion, and non-tail recursion. Next we have today's summary. Let's revise what we learned today. First one, calling methods. How to call a method. We are already know about that, executing a method's code by using its name with the parentheses. If we want to invoke any method from the main method, then we can call it with the parentheses. We have we can use it with the instance calling or static method calling. Instance calling means first we have to create the instance of that particular class, then we can invoke that particular method. Static, we can directly use the class name with the method name with the parentheses. With the parameters, without parameters, it's optional. Return values, we can put it some return values also. If we want to get some values in return from the method, then we can go with this one. Named parameters, if we want to use some variable name directly into that parameters, then we can go with the named parameters. We do not follow the sequence over there, but we have to use the same parameter name as that where we declare the method. Next one is recursive calls, where we want to call that particular method inside that method, then that is recursive calls. Next we have return types, specifying the type of a value a method sends back to the caller. Return value means if we want to send some particular value like integer string value from the method or from the method declaration, then we can return that value from there to main method. We have categories here, primitive types, we can get integer values, boolean value, double value, store simply value directly. Reference values is like string, arrays, classes, where we only store the reference of the value but not the actual value stored in the memory. But in primitive types, the actual data is stored into the memory. Custom types like user defined class, struct. Generic types, we have list of values, task of values. Next one we have a recursion, a method calling itself to solve a problem. If we want to call a method inside that particular method, then we can go with this approach, that is a recursion process. It must have a base case to stop recursion. If we want to use the recursion, we must have a base case where we put some logic, and if that particular logic is matched, then only the recursion part will execute, otherwise it will return that value or execute the remaining code. Here are the types: direct, indirect, tail, non-tail recursion. Direct recursion is that where we have one method and we are calling directly that method inside that particular method, so that is a direct recursion. Indirect recursion is that where we have multiple methods and we are calling that particular method from another method, so that is indirect recursion. Tail recursion is that if we are directly calling that recursive call inside that particular method, but not in the starting, not in the middle, only at the last of the method, then that is a tail recursion. Non-tail recursion is that if we are performing any other operations like addition, subtraction, multiplication, division, modulus, like that, then that is non-tail recursion, where on the last statement we are performing some additional tasks while using the recursive call. So these are the recursion. So these are the topics we studied today. You can practice them into your Visual Studio. If you have any doubt related with these topics, you can mention them into the comment section. So let's wind up today's session. Thanks. See you in the next lecture.